Question 4a. State the difference in basicity of ammonia, propane-amide, and the propylamine. Okay, explain your answer. Okay, because it's a 4 marks question, so first it's better for you to mention the basicity. Okay, the basicity, it depends on what? It depends on the lone pair on nitrogen. If the lone pair on nitrogen is more available, so it's more basic. So the first thing you need to put is this. Basicity depends on ability of the lone pair on nitrogens accept hydrogen ion. Means if it's more available, so it will accept the hydrogen ions better. So it's more basic. So now let's compare these three compounds. Which one is the strongest base? The strongest base, if we compare the ammonia and this propylamine, okay, so propylamine is a stronger base because this alkyl group is electron donating, so it will make the lone pair on the nitrogens more available, so it's more able to gain the H+. So the strongest base, it must be the propylamine. Okay. After that, followed by the ammonia, then the weakest base, it must be this propane amide. So the propane amide, because this amide group has this carbonyl carbon here. So this carbonyl group is electrons withdrawing. If you withdrawn electrons from this lone pair, means the lone pair on nitrogens, it will delocalize into this amide bond, this carbonyl, and eventually the lone pair on nitrogens here is less available. So it's all because of the carbonyl group here. So it makes the lone pair on nitrogens less available. So that's why we say that this nitrogen is a non-basic nitrogen, because the lone pair on nitrogen is always less available. Okay, if you understand the comparisons between these three compounds, then the first trend you should put propylamine as a strongest base, followed by ammonia and propane amide. Okay, so the first point I already told you just now. The basicity is depends on the this availability of the lone pair on the nitrogen. Then you just start to explain the strongest base. The strongest base is propylamine, because propylamine there is alkyl group, so it will make the electrons density on nitrogens more, and is therefore more available to get the H+. So the propane amide, why is the weakest base? Because the lone pair on nitrogens delocalize into the carbonyl group, as I told you just now. Okay, part B. Figure 4.1 shows two different ways to synthesize a propylamine. So from this figure 4.1, okay, this compound is the propane amide. So the propane amide, it can form this propylamine. So the reagent M, it must be the lithium aluminum hydride. So means it's used to remove oxygens from this carbonyl group and add two hydrogens here. So eventually it can form this propylamine. So this is the how to get this propylamine from this one. Okay, so how to get this propane amide? Okay, so then you need to relate to the ammonia here. So the K need to react with ammonia, form the amide. So it's quite clear. It should be the acyl chloride. So it must be the propanol chloride. So propanol chloride will react with ammonia then it can form this propane amide. So then the K, you should put this propanol chloride. Okay, after that, we move on to this this part, this bromoethane. So bromoethane with the KCN. So if you undergo nucleophilic substitution, so the cyanide here, it will substitute the bromines, and eventually it will form this propane nitrile. So it's 3 carbons here, CH3, CH2, Cn. And this propane nitrile will undergo reduction. We can use this lithium aluminum hydride, or we can use hydrogens with nickel. So it just add the hydrogens to this propane nitrile, 2 hydrogens on the carbon and 2 hydrogens on this nitrogen. So eventually you form this propane nitrile. Okay, so this is a reduction also. So then you should know the K, already discussed. This is propanol chloride, and the L is this propane nitrile, and M is the reagents that we use to reduce the 2 compound. So it's a lithium aluminum hydride. So it's better for you to put lithium aluminum hydride. Okay, so this is a reaction equations for the propanol chloride with ammonia, which to form this propane amide and HCl. So this is a white film, and okay, this is the cyanide. Okay, so it will substitute the bromine, and it form this propane nitrile. Okay, part C, compound N is shown in this figure 4.2, and this compound is treated with excess concentrated HCl, and this compound undergo complete hydrolysis to form 3 organic products. The products are isolated from the mixture at pH 4. Draw the structure of the 3 organic products at pH 4, means acidic. Assume the CH3O does not react. Okay, so this one doesn't react. Okay, then let's start from this the amide bond. Okay, amide bond it will be the one that undergo hydrolysis. So the bond break will happen here. So this carbonyl group will get OH. So it will form this ethanoic acid, right? So this carboxylic acid, and another amide bond will break here. So this NH, or these nitrogens, will get 1 hydrogen, and this carbonyl will get OH, because hydrolysis is going to form the amine and the carboxylic acid. So eventually it will form this amine, because it say that the organic products at pH 4. So this amine, it will further react with the hydrogen ion. It will gain the hydrogen ion and form this ammonium. So it will form this compound. So 2 products already produced. So is this ethanoic acid and this ammonium. So there is another larger part, so which is this one. So this part, okay, it will form the carboxylic acid, and of course this part will form the amine. So it means this one. So this carboxylic acid and amine, this one no reaction, because it's under acidic condition. The amines will react, gains the protons and form ammonium. So this is the last compound that produced. So there are 3 compounds here, 1, 2, 3, right? Just put into the boxes here. Okay, then that's all for this this part C. Part D. Compound P can be synthesized from 1-methyl 4-nitrobenzene. Okay, this one. 1-methyl 4-nitrobenzene. We slowly try to go through this step 1, 2, 3, 4. Then eventually it will reach this P. Okay, so now let's start from the step 1. So this 1-methyl 4-nitrobenzene, it will form this, see, the difference is here, the nitro groups and this amine. So it's from this nitro form this phenylamine. So for the nitrobenzene to form phenylamine, so we must use the hot tin with concentrated HCl, then followed by the sodium hydroxide solution. So this is always the reducing agent used to reduce the nitrobenzene to the phenylamine. Okay, hot tin plus concentrated HCl followed by this. So then from this compound, so this the compound after step 1 to form this compound. So the difference again, it will be the similar part. Now the amines, the 2 hydrogens is being replaced by the methyl group. So this one we need to use this chloromethane and the chloromethane in ethanol. This one you need to recall what you learned in AS. So the reactions between the ammonia with this halogenal alkene. So in this case is the chloromethane. So when we have the ammonia with the chloromethane, it will form this primary amine. So with HCl. So this is the reactions, means is very similar. This reaction is very similar to this step 2. So which the hydrogens here, okay, is replaced by this methyl group. As you can see, one of the hydrogen here is replaced by the methyl group after the reaction. So means if we want to let these hydrogens replaced by the methyl group, so we must use the methyl with a halogen, means in this case is the chloromethane. So it can form the 2-methyl group. Actually is involve 2 steps. So means, okay, the first one is this one. Let's say this is the alkyl group. Let's say this part, right? So it's the R with NH2 with the chloromethane. Then first it will form this. So the NH with 1-methyl group with HCl. Then this one will further react with this chloromethane again. Then these hydrogens will replace or substitutes by this another methyl, right? And of course it will form the byproduct HCl. So eventually it can form these nitrogens with 2-methyl. So which means step 2 reagents that needed is the chloromethane, and of course it must be in ethanol with heat. Okay, after the step 2 and this compound produced, then it will undergo step 3. Let's see what is the difference. Okay, this part now is same. Now the different part is the methyl group and the COOH. So obviously it's the oxidations of the methyl group that bond to the benzene ring. So in order to oxidize this methyl group, then we need to use the hot alkaline caminol 4, then followed by H+. Followed by H+ is just to do this so-called acidification to let the carboxylate form back the carboxylic acid, right? So you just follow this. Okay, after that, from this carboxylic acid, it is formed ester. So means it's going to react with one alcohol. So you can easily get the alcohol from this structure. Okay, break this bond, add one H here. And of course here is the OH This is for the hydrolysis of the compound. So means we can use this alcohol react with the carboxylic acid to form this compound P. So this is the alcohol that you should use. Of course, it must together with the catalyst, concentrated H2SO4, heat or reflux. Okay, that's the whole process for this from step 1 to step 4, right? Okay, the step 1 is again the reduction of the nitrobenzene to the phenylamine. So basically, it's remove oxygens and add hydrogen. So total hydrogen needed 6. So 2 hydrogens for the nitrogen and 4 hydrogens for the O2 to form this 2H2O. Okay, so this part I think no need to really discuss further for the reagents and condition. I already told you just now. Okay, all this, right? So you should know already. And the type of reaction is what? For the step 1, I already told you is a reduction. Okay, because it's from nitrobenzene to phenylamine. And for the step 2 is a substitution, right? So obviously the step 2 is we substitute the hydrogen with this methyl group. So it's a substitution reaction. And for the step 3 is oxidation, right? So the side chain here means the methyl group now oxidized to the carboxylic acid. Okay, the last one is given condensation to form the ester. Okay, so that's all for this part. Thank you.